All right, guys, in this video, we are going to take a look at conditional probability and also independence as it relates to a question where the data is given in a what we call a contingency table. So it's a 2 by 2 table where we have two factors that we're interested in. One is whether a student took statistics with Professor Luri, or second factor is whether student passed, failed. So let's take a look at the first part. The first part is what we call a conditional probability. So how do we know that? Because it says if a student didn't take stats with Professor Luri, so we have a certain condition that we already know, which we call a given or if. So now what you do is you concentrate on only people that did not take stats. And there were 57 people that did not take stats with Professor Luri. Out of that number, what is the number that failed? Because that's what we want here. We want to know what's the probability that the student failed. So we can see that there are 24 students that failed out of 57. And that will be the answer here, but we want to round it to 3 decimal places. So let's just open up the calculator. And let me see if I can resize it. So we get 0.421. Okay, for the second question, now it's also conditional probability. Again, we can see the word if. Sometimes they use the word given. If a student failed. So now we know that the student failed, and now we are in the column of failed students, which is 32 students total. How many of them did not take stats with Professor Luri? Well, 24. So that would be 24 divided by 32. So that is conditional. This is where you divide in by the condition. The number of students in the if part will always be on the bottom. So the number of students in the failed is 32, or number of students didn't take stats is 57. So you can see that then the condition is always on the bottom and the overlap or intersection is on the top. Now, looking at the next set of questions, these are not conditional. So if it's a not conditional question, you are always dividing by the grand total. Every one of these will have a bottom of 115. And the top should match whatever the condition is. So if we want to find probability of A, where A is a student failed, we want to see how many students total failed, 32, and divided by the grand total. So do not divide it by the condition now, because this is now not conditional but by regular probability. The next question says, what's the probability that a student did not take stats with Professor Luri? Again, this is not conditional. Look at all students that didn't take stats with Professor Luri, which is 57, and divided by the grand total in the table. If I round it correctly to 3 decimal places, that would be 0.496. Finally, this is a very tricky question. This is A and B. Now, remember that and in probability means at the same time, both at the same time. So it means that the student failed and at the same time, the student did not take stats with Professor Luri. How many people were like that? Well, we can see that there are 24. And again, because this is not conditional probability, you are dividing that by the grand total, which is 115. And so I get 0.209. All right, so for the next part, we want to check the test for independence. The test for independence says that two events will be independent if the probability of their intersection or overlap, which is A and B, equal to product of individual probabilities, so P of A and P of B. Let's check out whether that's true. Well, we already have the intersection, which is 0.209. Now let's multiply P of A times P of B. So that would be 0.278 multiplied by 0.496. And that gave me 0.138. Okay, so I need to compare these two answers. If they're the same, then yes, independent. If they're not the same, then no. And obviously, these two numbers are not the same, so I'm going to choose not equal, which means that these two events are not independent.